did it only for the chocolate, glad to hear. Good, and I cannot believe how well this transitions to the next talk, because last time Torsten did a presentation about a use case at Festo where rules were really important, and you showed how you reduce the complexity there. And now we have the same backend, RDFox, with a use case from BMW. Super happy to have Haonan Qiu and Peter Crocker for the next session. Thank you.
Thank you. And yes, thank you, Dave, for setting it up, setting the stage. Thank you. So my name is Peter Crocker, joined by Haonan. Please come to the stage. And we're here to talk about reasoning. We're here to talk about rules, and specifically reasoning on the road. So how can we take some of these concepts and apply them in real time to situations that are incredibly dynamic? And if we can apply them to those types of situations, well, I think we can apply them to many others as well. In terms of the agenda, I'm going to run through just a very quick setup in terms of who we are, the company that's built the product that we're then building some of these capabilities on. But I'm not going to spend much time. I'm going to run through. Really what I want to do is hand over the stage to Haonan, who's the star of the show, to talk us through a practical application of this in her work. So the company itself, we're Oxford Semantics. We are a spin-out of the University of Oxford. Creating a reasoner is hard. We're very grateful for all the work that's gone in at the university, and many universities have collaborated with them to create what is now the product and the foundations for our company. I'm blessed with some fantastic co-founders in the form of the professors out of the department. We live, we breathe knowledge representation, but also this aspect of reasoning that we're going to be talking about. Our product is RDFox. We have investment, we have plenty of customers, but that's not really why I'm here to talk to you about. I'm here to talk about helping you answer what can seem, as we were just hearing in the last session, complex questions. But we're interested in doing that quickly, and how we do it is by combining human knowledge, and quite often human knowledge that can be expressed with some fairly simple steps, but where the collection of those simple steps leads to potentially complex systems that can answer those questions. And we're all about rules-based AI. We were built primarily as a semantic reasoning engine. To do so, we had to tackle some problems in terms of speed and scalability. We were hearing from Dave some of the challenges that reasoning presents has in the past led to problems around speed and scalability. Well, we started with that as the basis. That was the first problem to tackle. And as a result, we've ended up with a very fast reasoning engine, but also a very fast query engine as well. And we'll see some evidence of that in a moment's time. In terms of reasoning, everyone talks about reasoning, but what do we mean? Because it can mean different things to different people. Well, we do everything that you probably expect and anticipate. If you're coming from an OWL or a swirl background, you will understand some of the concepts we do. Our focus is to include all of that capability. We infer, we materialize relationships, but we can also, within our setting, and we're going to hear plenty of this from Haonan, embed calculations into the rules, aggregation, negation, things that we're familiar with from a query perspective, but we can bring that to rules as well. The advantage, as we were hearing from Thorsten's question, of doing this reasoning is full explainability. So any fact that's inferred, any fact that's materialized into the graph, we can show you the full trace of where that came from, effectively the human knowledge that has led to that conclusion. And finally, we provide incremental reasoning. So in the example we were hearing about compatibility just now, if someone was to make a change using our system to one of the interfaces, if they were to make a change to that temperature range, for example, incremental reasoning will kick in, and any incompatibilities that are now present in the system will automatically be added to the system. And now, the next time someone queries, those consequences have been updated, and that's all done with a database, right? So all the benefits you get of a database, transactionality is all inherent in the system, all the way through to how we do the reasoning as well. We claim to be fast, but please don't take my word for it. Run your own benchmarks. Don't trust a vendor. Run your own benchmarks. Go and read literature. Here we're sharing a published paper where we're not naming everyone. We're just putting ourselves at the top, which is where we are around import times and around query times. So not only do we do all this reasoning, to do fast reasoning, you also have to have a fast query engine. We've combined the two, and that's where we come from. In terms of customers, we have customers from a very broad range of industries. I'm sure many of these industries are represented in the room. I'm not going to go through all of these. What I really want to do is focus now our attention on automotive and invite Haonan to the stage.
Hello. Am I audible? Yeah, perfect. Yes, great honor to be here. I think rules and ontology was like in the old time, 10 years ago, it was mostly, like the paper that I can find was quite a lot in robotics and also some automotive companies, they tried as well. So I'm personally very glad that I'm still working this domain with ontology and rules. So I'm going to present like some of the pains, like there are several ones, but those pains are shared in other domain as well. So it's not exclusively only happening in automotive domain. But some of them are like, for instance, the increased complexity, where like the cars at the beginning you have one ECU, now there are like hundreds of ECUs. In each of the ECU, they have like the embedded code to do their dedicated jobs, which resulted in isolated data processing, and the code is often duplicated doing the same thing. As well, the logic are coupled with the data, and it's difficult to integrate data across different ECUs and systems. So these are common issues that is so-called application-centric architecture issues. That leads to one of the, I think that most of you probably already are familiar with this data information knowledge and wisdom pyramid. So we are as well focusing on that. So we wanted to shift from all application-centric mindset into data-centric architecture that actually provides a conceptual framework to utilize the data, then offers integration and insight. I think a lot of work has been already done on the information layer, and so we are taking it to the next stage. At the moment, focusing on knowledge layer using ontology, shackles, rules, and queries. But that is not, to say the knowledge layer can be a layer that combines numeric approaches with symbolic approaches. So, what kind of benefits that we see as using rule engine here? So I would like to take this analogy. So we consider like the rule engine having a similar benefits as how the mobile phone operating system they provide or the ecosystem that they had. That usually an application can be rapidly developed and deployed on the mobile phone, and then it does, so the operating system of the modern mobile devices provides the scalability and rapid adaptation. We see the rule engine also have that. So based on that, the user, or you do need to bring your logics, for instance, checking your health. You have a lot of smart data coming from your iOS watch to track your steps. And some of the things can be easily reasoned upon using rules for the drivers, for the passengers, as well for the right-of-way. Can clearly see which car has to yield. And even as like modern, like the cars has a lot of maps embedded, the map processing, do you have a next lane? Do you have a left lane? Is the car gonna reach somewhere based on the map data? So there are a lot of relationships that can be built during rules. Plus ranging, like in this case, it does provide the advantages that we see, like deterministic, explainability that is essential, as well as transparency, because we would like to show whatever you see that is running, whoever wanted to know what's the logic behind it, they can open the file that contains the rules. They can start checking it. What was it there? So there's no hiding behind the code. Okay. So. All right. So it works now. But how did that make that rapid development happen? One does have to bring the logic. Well, so we say like bring your logic only. So you will have like input and output into this module which contains a rule engine. One is to structure the so-called program using rules. I do have to have ontologies or shackles that as to define the schemas and how the data should be structured. Then you have a set of rules to provide the basic building blocks. At the end, what the output should look like. And then at the end, the Sparkle query can as well be just assembler that assemble pieces together to provide the output. To make it simple, we see as only 2 steps. The first step would be like step 1, we do need to know what's the input and what's the output. Then step 2, obviously, to build the chain between the input and the output. Next, I can show a very simple example. That's what we did with set ambient light of the driver, that the input data is just some VSS data points that gives the status of the ambient light. And output, we want to know for certain service that can I actually change the ambient color to certain predefined values that was preferred by the user. Doing so, one can just introduce the rules to encode the pre-checking logic. And now you see the advantage is if the pre-checking condition needs to be changed, then this can be easily done by the rules. So for instance, the temporal aspect can be captured as like current ambient light by capturing the value of the timestamp. This is our implementation. So this is a zone architecture of the vehicle. I'm going to focus on 2 layers, how this is implemented. So information layer, there is a data middleware. The solution is provided by MongoDB, and that is to say for almost all the ECUs, they're deployed this data middleware that is responsible for synchronizing the data. And then on top of the information layer, which is implemented using MongoDB, we have knowledge layer, which we use the RDF aux, that to derive use case dependent inferences. And those information, so the inferences that is derived later on is actually stored in the data middleware so that it can be synchronized all over the system. That is to say, all the ECUs on the onboard as well as the backend database. Then we also deployed another RDF aux encapsulated application on the backend that for instance, to only reason upon the information which is available on the internet. So the same infrastructure which you just see, we actually was able to implement or realize 3 completely different use cases. One is so-called daily user trip that basically just captures the GPS position driving status that to infer a representative trip out of the user. And the other one is so-called vehicle service. Like probably you'll have this smart opening door, changing ambient light. These, we use the rules to encode the pre-request conditions. As then the last one was radio station recommendation. And the structure is the same as what you said before, so you only have 2 steps. You identify what's the input and output. and how you build the chain than using the rules. Next, I'm going to show a very fast video. This is the second use case I just showed, the service execution. Here, what you're seeing is that we have a fast developed UI that is on as a mobile phone application. That just to show what does the service description look like. And what is intended to do is to be able to activate the ambient light when certain conditions are fulfilled. And checking whether certain conditions are fulfilled, those are used by rules, which is already running in the system. So it's pretty fast. I'm going to just show something key points. So what is important here is the rule description. So in general, a service can have not only one required condition, can have combination of such. For instance, at some point, maybe the ambient light should just be turned when it is off. But maybe the other time would be like you check only at certain point based on your GPS position, so geofence. You say, well, only in this location I want my ambient light to be yellowish. Or you can also combine with temperature. So these conditions, they should be flexible and be able to be extended. The traditional way of doing this will be very costly. By using rules that one can update, or the rules that is already used on the vehicle can be much more faster. So I'm just going to skip. And what's next? We do want to put standardization effort that to be able to identify what are the building blocks for semantic web-based technologies to be able to use in automotive field, especially as well, for instance, to identify the reasoning mechanism and capabilities, and having certain profile that is predefined so that can be reused and shared as a guideline, or as well, for instance, common knowledge definitions. They already work, like they are existing work, and they are still effort putting into this domain. And then extending knowledge layer, for instance, with machine learning, potentially with large language model as well. Maybe just an invitation. What I just showed here as this infrastructure, this is also proposed in the EU project, which is so-called hardware abstract layer for software-defined vehicles, because we do see great potential. So this is going to the notion of zero code implementation. As well, there's a joint space called Coveza, where we also actively trying to share what we are doing inside BMW to this public space so that it can be accessible to the great majority. That we are working on a playground project which is open to everyone. So it's not necessarily only in automotive domain. Whoever is interested in such technology and wanted to contribute to the application usage into automotive domain, this is open for invitation now. And also, like, we want to put effort into benchmark as well, something into the direction of how machine learning community they're doing with their lead board. If there's possibility, we define certain reasoning tasks and then provide the data sets from different OEMs, the vehicles, and then everyone just can join and then try the solution and see which one is the best. Yeah, so this is the invitation. At the end, the practical steps on how to get started, I think there are a lot of them. I thought the most important one would be just to start it. The second part is, I think in terms of the practical usage, identify where is the data pipeline that is suitable to replace the current solution with rule-based approaches. Once you identify that component, then extract it out, try to plug in your rule-based approach. Now stitched it with input and output. See how you can make the data flow first before going to the ontology and rule designing. For me, that's so important in terms of practical realization, first of all, and do investigation on what's the reality of the current infrastructure, and then be able to make sure that your approach is actually going to be able to deploy and receive the data and output the data. Then start with ontology, but grow the relationships with rules. I would very much, my personal experience, start with some core concepts of ontology, not necessary to be perfect, but it gives you the building blocks and the vocabulary to start. But to make it mature enough, start with the rules. Grow your relationships. Try to understand what is the concept related to the other. And I think rules is as well as a great tool for thinking the relationship through. Yes, so I think I will end with this.
So then, just to wrap up, why knowledge graphs? Well, I'm not going to talk to that. We're all here because we believe in knowledge graphs. I think to quote earlier, we've bet our careers on it, right? But what I would ask you to think more about is why reasoning and rules. It's a way of encapsulating. It's a way of encapsulating a form of knowledge. And what we saw here was examples where you can go beyond what we're used to or maybe familiar with from an ontology into calculating and having the machine do the things that otherwise you would have to maybe write some pretty complex queries for. By encapsulating these small ideas, incrementally materializing those, you can achieve a much more rich experience. Why RDF-Fox? Well, for this example, because it can run in a car, but it can also run at large scale and speed. And yeah, I encourage you to please come and find us. And if you have reasoning or rules-based applications that you think might be applicable, we'd love to hear from you. For questions, I'm just going to leave a couple of QR codes for follow-up. But thank you. That's what we have for you this morning. So, any questions?
Hello.
Hi.
Thanks for the talk. I've implemented a little data log engine, so I'm a big fan of RDFox and like read these articles and things. I haven't used it myself, but I can see what you mean by like rules making understandable, explainable reasoning sort of available for the masses. My question to you, I also have not much idea about the RDF tools. I know they exist essentially. But one thing that we've heard was that there was a standard for RDF, and right, like standardization, of course, comes with it, creates like an ecosystem, because now a lot of people can sort of join the club and build products. And surely there are vendor differences, but still it's the same thing. Like, and we've also heard it in one of the talks that the data store provider is exchangeable, so that's what standards enable. If you now look at data log, which is arguably closer to the formal model, to predicate logic, to everything, where do you see sort of a potential for standardization in a way that maybe some of the ecosystem can be carried over? I do think that you support probably RDF and everything, so I really don't have detailed knowledge. But when it comes to standardization on the data log front, suddenly we speak about a different syntax, different, like where do you see that? Is there any? Yeah, anything?
No, great question. So yes, absolutely. We're great advocates of standards, and I think I have to say that because some of my directors were chairs, were co-chairs, were part of the standards bodies that created many of the standards that we're built on today. So yes, I'm a big fan of standards. Datalog, I think, has existed pre many of the standardization movements. So it's been around for, well, we can almost think of it as a de facto standard, even if it's not ISO certified or whichever standard body. I would love to get involved in a group that wished to standardize Datalog. So the invitation is there, and we'd be very happy to participate in that. And we're seeing we have a number of connections and other companies that are very interested in Datalog, that are internally building their own products using Datalog. So I think there is critical mass will start forming, and as people realize that, the power of reasoning, they'll be more interested in that. So yeah, thank you. Great question. And sorry, just one more thing. You should really try IdeaFox. It's very easy to get started with. Sorry.
Yeah. Just to confirm, if I understood correctly that those rules were used to kind of abstract the knowledge and to generate the knowledge.
So Haonan, one for you probably.
And the second one, quickly, how do you see maybe some non-deterministic rules, some dynamic way to do it?
Yeah, great. So the question was around the rules we use to, I guess, digitize some otherwise abstracted knowledge. So for example, the concept, we've talked about the concept of a lane, the concept of when you can change lanes and the like.
Short answer, yes. So rules are used to not just conceptualizing, but also putting those concepts into relationship that makes sense to your use case. So also, I think in terms of how we think, how we reason in our head, usually that's how it's reflected in the rules. Given that you have those building blocks already provided in terms of ontology. So it's more of a thinking to build a chain from one place to another. While ontology itself gives you the vocabulary in the graph structure, which is very flat, but I think the rules give you a tool to build the chain along using the concepts that you have. Yeah.
And sorry, was there a second part?
Non-deterministic way.
Non-deterministic, yes. So to bring in things like fuzzy logic, I guess, right? So non-deterministic, and yeah, from going back to expert systems, this concept of being able to introduce fuzzy logic. So IdeaFox, the product, does not out-of-the-box support fuzzy logic in its classical sense, but we have mathematical operations built into the language. So these systems can be implemented using capabilities. So this is going to sound contradictory, creating a non-deterministic or fuzzy system using a deterministic system, right? But with mathematical operations.
Yeah, I was more about context dependency of the context is changed, it's dynamic.
Oh, of course, yes. So your rules can have multiple axioms to them that bring in the context and all the rest. Yeah.
Hannah, what were the challenges of implementing the rules real time?
In real time, let's say in build time, it's debugging. In real time, if I understand, in real time, you mean the system is running?
Yeah, you run it on the vehicle, right?
Yeah.
So these rules are running.
Do you mean complexity-wise, or how complex?
Both, complexity, process.
How do you make sure the car doesn't need to stop? Right? Yeah.
Or how? Yes. So I understand. So the processes, I usually start with building my rules and with simulation data that goes in to verify if my rules are correct. So sometimes what happens is, first of all, you have to be stratified, that you don't have dependencies. So these are one of the challenges. Another one might be sometimes you have a big block of rules just because I thought this makes sense. But then actually you have to chop it down into smaller pieces so that you reach a certain improvement, optimization of your performance, for example. And at some point you also realize, oops, I'm writing repeatedly pattern of the rules. And then you realize I probably need to refactor it and then make it more generalized such that this rules actually is suitable for several cases. So they are those challenges one can identify during the process. As well, for instance, when writing the rules, I might notice my ontology designing wasn't that making, it looks perfect at the beginning, but when it doesn't really work well with my rules, I needed certain attributes or properties so that I can make the rules more clean and neat. So then I may go and change the ontology. So yeah, these are some of the challenges, and also build incrementally to verify each step whether this is what I desired as output. Yeah.
If I can just add one there, incremental reasoning is also your friend in this setting. If you can follow all of the strategies that Haonan just described by breaking the logic down into component logics, incremental reasoning will ensure you only have to compute a part of that once. So you might have what is effectively a complex question to ask of the system, but much of the work has already taken place. So you're only paying if you use reasoning correctly, you're only paying the computational price once. You're not paying it every time you run a query. And that's really important, especially when you need a fast dynamic system such as this.
Good. Perfect. Thank you very much again.